Hello, everyone. We are on our last section of the chapter for area, surface area of pyramids and cones. So let's talk about a few things here. You name a pyramid by its base shape. So since this base is a pentagon, this would be a pentagonal pyramid. The base of this pyramid here is a triangle, so it'd be a triangular pyramid, right? And the cone is just straight up a cone, right? There's nothing fancy about a cone. A few other things. Ooh, this is not ideal. Okay, hold up. Let's look at, do it this way. Oh, much, much, much better. Okay. So we have some things we gotta talk about with a pyramid here. Obviously, the bottom, that's not a triangle here, is its base. So this would be like a rectangular pyramid. What build up the pyramid, they're always triangles, right? Because it comes to a point, which we call the vertex. The altitude is actually like how tall it is, and it's in the inside of your pyramid. Like you can't see it if you're just to look at it. It's on the inside because it has to be perpendicular to that base. But then we have another thing called a slant height. And now a slant height is the height, of the lateral, can you guys see that? The height of the lateral face. So it's the height of that triangle. Take a second to write down whatever notes you need to, and then I'm gonna flip the camera to me so I can just kind of show you, because this is what I would do in class if we were together. But of course, here we are in week 5 of this pandemic. Okay, I'm gonna flip the camera to me. Bum, 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 bum. Okay, here I am. So, do you guys see how this is my pyramid, right? Pyramid, pyramid, pyramid. Okay. Now, my height of my pyramid is on the inside. So like this red pen would represent my height of the pyramid. Right, it's going to be the perpendicular distance from the vertex, that peak up here, to the bottom base. Okay, that is my height of my pyramid. Now, the slant height is the height of this actual triangle base. Sorry, this guy right here. Oh, this is terrible. So if I wanted to figure out how tall, bad marker choice, would be right here. Like this is a slant height. It's slanted, right? Because the side of my pyramid is slanted, hence why it's the slant height. So this right here is my slant height. This right here is my height. Does that make sense? I hope it makes sense. If not, let me know. Let's fix it. Let's fix any questions we have. Okay, going back to notes. Surface area of pyramids. Okay. All right, we start off with a doozy. We love that, but it's a good review for us just because it's been a week since we've done a problem like this. Everyone's favorite, it says, find the surface area of this pyramid. Now let's look here, folks. We have a 6-sided figure on the bottom, which makes it a hexagonal pyramid. Okay, so now from here, we have to find our base area. Well, how do we find the area of a hexagon? So I know we have to first start off with the angle here, so we can figure out this triangle. You guys remember this from like last week? So 360 divided by, there's 6 sides, not 2, is 60. Now divide that by 2 and we get 30. So this angle in here is 30. And we are looking for our apothem. Remember our formula. Area equals half our apothem times perimeter. I know our perimeter would be 5 times 6, which is 30. Now we have to find out what our apothem is. So this little guy right here would be 2.5 is our short side. And now our long side would be 2.5 times the square root of 3. What is that approximately? 2.5 square roots of 3. About 4.3-ish. So now if we plug into our formula here, our Potham equals 4.3. So half our Potham times 30 gives us 64.5. So that is our base area. And now our lateral area is just made up of triangles, right? So the formula for a triangle is half base times height. Our base, what is the base of this side? Well, it's 5. And now what is the slant height of that pyramid? It's 8. So I'm going to get half of 5 is 2.5. 2.5 times 8 is 20. Now, how many triangles make up that pyramid? Or aka, how many sides does the base have? Well, it has 6. So 20 times 6 equals 120. So our total surface area, 120 plus 64.5 is 184.5 centimeters squared. Not really a great problem to start with, and I apologize, especially when we're not together. I don't believe I put a problem like this on your homework, but again, just a good review, and the process is the same no matter what your base shape is. Okay. Let's try a different one. It says find the surface area. This would be a square pyramid. I guess we can just assume, since they're not telling us what the other side is, so we'll just call it a square pyramid. Okay, let's start with our base area. Just a square, so 12 times 12 is 144, easy enough. Now our lateral area, remember, is just a bunch of triangles, so half base times height. Our base is just 12, but now we're missing that slant height, so we need the slant height. But we are given our actual height. So if you guys notice here, look, it makes a right triangle. I'm going to draw it right here. This is 16. Here's my right angle, but look, you want to assume this whole thing's 12, right? But look, it's only half. So this is actually 6. And now we can find that missing side for our slant height. That's our L, our slant height. So Pythagorean theorem all day, right? As always, so 16 squared plus 6 squared equals L squared. 16 squared is 256 plus 36 equals L squared. 256 plus 36 is 292 equals L squared. Take the square root and we find that it is about 17.1. So now that we know our slant height, I can plug it in for our height. So if we crunch this out, half of 12 is 6. 6 times 17.1 is about 102.6. How many triangles build up that pyramid, aka how many sides does the square have? Well, it has 4. So multiply that by 4 and you get 410.4. Now our total surface area, add these up, 144 plus 410.4, and we get a total of 554.4 centimeters squared. All right. Lots of triangles today, but that is all right. Okay, we are moving on to a cone. I'm just going to show you this one because it's a better, I don't want you to see that yet. Okay. So it's kind of like a cylinder. We have a nice formula that we get to plug into, so it's going to be easy peasy. A few things to talk about. Again, we have a height that falls inside of our cone and a slant height that's on the outside, right? Because this is kind of hidden, it's inside, just like the pyramid. And again, we can have a right cone and an oblique one, that one that's kind of pushed off to its side. Now, how you find the surface area of this, we can kind of talk about it. The surface area, remember, it's your base area. Well, our base is just a circle, so it's pi r squared, because that's how you find the area of a circle. And then when you unravel a cone, you get this really weird kind of fan shape. So here's my cone, and now there's my base, my circle, pi r squared. And now when you unravel it, look, you get like this fan thing. This is what it looks like. Okay, so the formula to find the lateral area, that fan, is pi r l. Pi times your radius times your slant height. Okay, so jot that down, and then we will do this last example together. Okay, so it says find the surface area. Strictly plug into the formula. Our surface area formula is pi r squared plus pi r l. Okay, so what is our radius? Well, they tell us our radius is 6, so I'm going to plug in pi 6 squared plus pi 6 and our L. Of course, why would they not give us that? Well, we can find it though, because again, it's just another Pythagorean theorem. 7 squared plus 6 squared equals x squared, or our L squared. Crunching these numbers out, 49 plus 36 equals x squared. Adding 49 and 36, we get 85. Square root of that, about 9.2 is our slant height. So plug in 9.2. And now we just simplify like we did with the cylinders. 6 squared is 36 pi. 6 times 9.2, about 55.2 pi. Add up our pi's, 91.2 pi, multiply by pi. And this is approximately 286.5 inches squared. Okay, folks, that's all I have for you this week in terms of video lessons. Finish the week strong, get outside, enjoy the sunshine, be good, be kind, onward, central, live the tradition, all those things. Kindness week, miss you all. Oh, and if you've made it this far in the video, Winnie's birthday's coming up, and if you can guess what her birthday is and email it to me, or actually put it on your assignment. Encircle it, put it somewhere by your name, so I don't have like 8 million emails. Actually, no, because it's sometimes hard to see your assignments. Email it to me. If you want to guess Winnie's birthday, and if you get it correct, I will give you a bonus. Don't tell anyone. This is a bonus for you for watching the full video and playing along with my game. So if you make it this far, shoot me an email of when Winnie's birthday is. It's kind of a fun birthday, and I'll explain it later when it happens, or why I think it's fun. And I'll tell you that it hasn't happened yet, and it's before school gets out. Okay, enjoy the rest of your week. Miss you all. Talk to you soon.